The inspector believes that the number of late buses per day driven by the new driver is 1.75. Not 1, it's 1.75. It's split over a line. Later, the inspector notices that a 4-day report contains only 5 lates and wonders if the number of late buses per day driven by the driver is now less than 1.75. Assuming a Poisson distribution and stating your hypotheses clearly, carry out this test at the 10% significance level. Hypotheses, first of all, H0, it is 1.75 a day, as originally expected, which means lambda is 1.75. H0 was it is less than 1.75 a day. There's a mark for each of those hypotheses. Because we have a less than sign in here, what does that tell us about the test we are doing? It's a one-tail test, and we're told to use the 10% significance level. So we've got to see whether 5 in 4 days is significant. So if we're dealing with 5 days, we need to scale up, which we've done down here. So if it's 4-day period, 1.75 times by 4 is 7. So we're going to be using lambda as 7. We need to find the probability of getting what we observed, which is 5, or more extreme. So in other words, 5 or fewer. And if that is less than 10%, so if the chance of getting what we saw or more extreme is less than our significance level, then we will reject H0. And I think it's sometimes worth writing that down before you get to the end, just so you can show that you know how you're going to interpret your conclusion at the end. So, we work out the probability x is less than 5, well you can just get that straight from the tables. That's 30%. So that is not less than 10%, so we do not reject H0, we accept H0. So we accept that the lates have not changed, they are still 1.75 a day. So mark for the null hypothesis, mark for the alternative hypothesis, mark for scaling up lambda, 2 marks for the probability, and 1 mark for your conclusion, 6 marks altogether on question 10.